Long before water ever touched its sand, the Negev desert was a place defined by absence. No rivers, no lakes, no mercy. Beneath a sun that punished the land without pause and winds that reshaped the dunes day after day, survival itself seemed like an act of defiance. Few places on Earth appeared more unwilling to host life. And yet, against all logic, this landscape would become the stage for one of the most extraordinary transformations ever attempted by human hands. This is not a vision of the future, nor a scene from a science fiction film. It is the real story of how Israel combined science, engineering, and relentless determination to do the unthinkable: make water flow where none should exist. In a region once written off as permanently barren, life would return, not by chance, but by design. The Negev, long seen as a symbol of desolation, was turned into proof that nature's limits are not always final. This is the story of how Israel brought the sea into the desert, creating artificial rivers that would permanently reshape the land. And it all began in the scorching heart of the Middle East. But before we begin, don't forget to like the video and subscribe to our channel. For centuries, the Negev was regarded as a merciless land. During summer, temperatures routinely surpassed 110 degrees Celsius, 43 degrees. Rain appeared for only a few weeks each year, and the underground aquifers that once supported life were slowly disappearing. Nothing seemed able to endure for long. Crops failed, livestock perished, and farmers were forced to abandon lands their families had worked for generations. Entire villages that once thrived faded into ghost towns, their wells reduced to dry dust. To survive, water had to be hauled in by trucks from distant regions, an expensive, fragile solution that kept communities barely alive. Yet, just beyond this endless ocean of sand lay another sea, the Mediterranean. Vast, blue, and saturated with salt. To most, it was useless for human survival. To Israeli scientists and engineers, it represented possibility. The question that drove them was both simple and radical. What if the sea could be brought to the desert? What if salt water could be transformed into fresh water and dead land could bloom once again? In the early 2000s, this bold idea became national policy. The Israeli government launched what would later be known as the Desert Water Project, an engineering effort so ambitious it seemed to challenge the laws of nature themselves. The investment was immense, nearly $3 billion, but the objective was unmistakable: make rivers run across sand and turn seawater into life. The first obstacle, however, was not technology. It was the desert. The Negev's unstable dunes made construction brutally difficult. With every strong wind, entire sections of progress could vanish overnight, burying months of work beneath shifting sand. Engineers knew that before digging any channel, the terrain had to be mastered. So they began by mapping the region with high-resolution satellites and ground-penetrating radar, studying every inch of the land. Boreholes more than 100 feet, 30 meters deep, were drilled to understand the subsurface layers. Nothing was left to chance. Every stage, every slope, and every curve of the future canal was calculated with inch-level precision. Then came the transformation of the terrain. Hundreds of tractors, graders, and excavators advanced across the desert. They leveled elevations, filled depressions, and reshaped the landscape to create a solid foundation for construction. Moisture became an essential ally. Engineers discovered that by spraying groundwater over the sand, it could be made to bind together. Once damp, heavy compaction rollers compressed the soil, creating a resilient surface capable of supporting the immense weight of cranes and trucks. Little by little, the desert stopped looking like a wild expanse and began to resemble a gigantic construction site. Then, excavation began. Every day, more than 77,000 short tons of sand and soil were removed. Over 200 engineers and workers labored under intense heat, close to 115 degrees, 46 degrees. The main canal stretched for about 250 miles, 400 kilometers, with an average width of roughly 148 feet, 45 meters, and a depth of about 23 feet, 7 meters. The required precision was extraordinary. The slope could not vary by more than 1 inch every 100 feet, about 2.5 centimeters every 30 meters, or the water would not flow properly. Laser leveling systems ensured this precision along the entire length, and the excavated sand was reused to build large containment embankments along the sides. But there was an even greater problem: the desert's thirst. Any unlined canal would quickly lose its water to the porous soil below. To solve this, Israel built one of the most extensive waterproofing systems ever implemented in the region. The canal bed was leveled and then covered with concrete panels about 4 to 5 inches thick, 10 to 13 centimeters, each measuring approximately 16 by 10 feet, 4.9 by 3 meters. Between them, expansion joints filled with bitumen allowed for temperature variations without leaks. In areas with weaker soil, engineers added a high-density polyethylene membrane beneath the concrete, anchored with steel bars. The result was a fully sealed canal, capable of storing billions of gallons of water without losing a single drop. To further reinforce the structure, vegetation was planted along the banks. Species such as vetiver grass and desert acacia were chosen for their ability to withstand extreme heat and stabilize the soil. Their roots prevented erosion and stopped sand from being blown into the canal by the wind. Seen from above, the completed project looked like a silver ribbon gleaming amid a golden ocean. It was beautiful and strange, a river where no river had ever existed before. This was not just a canal, but an entire hydraulic ecosystem. Along its length, hundreds of auxiliary structures were built: bridges, siphons, aqueducts, spillways, and culverts. These structures were designed to handle both seasonal floods and the circulation of maintenance vehicles. Every few miles, massive steel gates regulated the flow to secondary branches, ensuring precise balance throughout the network. In practice, Israel had created a system of artificial rivers controlled by machines and mathematical calculations, not by rainfall or geography. After 15 years of relentless work, the moment of the final test arrived: the release of water. Engineers opened the gates cautiously, starting with low flow rates and increasing them gradually. Sensors monitored every variation in pressure, temperature, salinity, and ground movement. For hours, everyone watched the data on the screens until, finally, the impossible happened. A wave of seawater surged through the empty canal. For the first time, the Negev desert echoed with the sound of running water. Residents and construction workers gathered to witness what they called the rebirth of the desert. Cameras captured the shimmer of water advancing through the canal, as if life itself were returning to the sand. Elder farmers wept. Children played in the shallow sections. It was a moment of triumph, not only for Israel but for human ingenuity as a whole. Yet this was only half the journey. The water flowing through the canal was still salty and unfit for consumption. To make it usable, Israel turned to one of the most advanced desalination systems in the world. Along the Mediterranean coast, massive desalination plants had been quietly developed over the years. Now, they were ready to fulfill their role in this grand project. Inside these facilities, seawater first passes through mechanical filtration to remove sand and oil residues. It then flows through nanofiltration units that retain smaller impurities. But the real transformation happens in the reverse osmosis chambers. There, high-pressure pumps force the water through ultra-thin membranes that allow only pure H2O molecules to pass, leaving behind salts, heavy metals, and other contaminants. The result is clean, crystal clear, and safe water, yet almost too pure. It lacks essential natural minerals needed by the human body. For this reason, engineers reintroduce elements such as calcium and magnesium, balancing taste and nutritional properties. After that, ultraviolet light and ozone provide complete disinfection, and a small amount of chlorine is added to keep the water fresh during long-distance transport through pipelines. Every stage of the process is digitally monitored in real time, 24 hours a day, pressure, pH, flow rate, and purity. Once it meets the highest standards, the desalinated water is directed to large underground reservoirs and then into the main canal system. From there, it travels hundreds of miles across the desert, supplying cities, industries, and farms. What was once an impossible dream had become an everyday reality. Seawater transformed into drinking water and into sustenance for an entire region. The effects were immediate and profound. Within just a few years, arid lands began to flourish again. Farmers returned to cultivate areas where nothing had grown for decades. Drip irrigation systems, another Israeli innovation, began delivering precise amounts of water directly to plant roots, reducing waste. Green fields spread across the sand, and villages once abandoned came back to life. Schools reopened, businesses re-emerged, and for the first time in generations, the desert seemed alive. From space, satellites recorded this astonishing transformation. Where there had once been only shades of brown and gold, a vibrant green band now cut across southern Israel, like a living vein nourishing cities and farms. It was a man-made miracle, proof that the boundary between the possible and the impossible depends only on vision and determination. And as the Negev continued to prosper, it became clear that Israel's transformation was far more than a simple engineering success. It was a redefinition of the very concept of survival. For decades, the desert had been seen as the ultimate limit of what human civilization could endure. But now, orange groves, vineyards, and long rows of date palms stretched across areas that had once been nothing but barren land. The same ground that once cracked under the scorching sun now overflowed with life. Farmers who had once fled the desert were returning, drawn by a promise finally fulfilled. Their grandparents had dreamed of this moment, and now it had become reality. But this achievement did not emerge out of nowhere. It had deep roots in Israel's long history of water innovation. As early as 1953, decades before the Desert Water Project, Israel launched the National Water Carrier, a revolutionary infrastructure designed to transport water from the Sea of Galilee in the north to the arid south of the country. This system was the first major national attempt to balance water distribution, ensuring that every drop could serve multiple purposes: agriculture, industry, and domestic consumption. The project took 11 years to complete and cost around 420 million Israeli lira, an extraordinary sum for a young nation still facing economic hardship. Even so, it was completed in 1964 with the capacity to transport up to about 19,000 gallons of water per second, roughly 72,000 cubic meters per hour. That project laid the foundation for everything that followed. The National Water Carrier gave rise to a culture of water management that today has no equal. Every citizen became part of a national effort to conserve and respect water. From urban homes to desert farms, efficiency became the central focus. Technologies such as drip irrigation, developed by Israeli engineer Simcha Blas, revolutionized agriculture worldwide. His system delivered small amounts of water directly to plant roots, reducing waste and increasing productivity. This invention turned Israel into a global model of water efficiency long before desalination took center stage. When desalination technology matured, Israel was already prepared to lead. Its engineers refined reverse osmosis to an almost artistic level, continuously lowering costs and increasing output. Within a few decades, the country built a network of massive desalination plants along the Mediterranean coast, including facilities such as Sorek, Hadera, and Ashkelon, each capable of producing more than 150 million cubic meters of clean water per year, nearly 40 billion gallons annually. Together, they now supply around 80% of the water consumed by households in Israel. Water scarcity, once a national nightmare, was replaced by abundance. But Israel did not stop there. The country created a recycling and reuse system that turned wastewater into a valuable resource. About 90% of Israel's wastewater is treated and reused in agriculture, the highest rate in the world. This treated water irrigates vast agricultural areas, sustaining everything from citrus orchards to vineyards. What most nations discard, Israel transforms into life. This integrated cycle, from desalination to recycling, ensures that not a single drop is wasted. The Desert Water Project, combined with desalination, became the final link in this chain of innovation. The goal was not merely to bring water to the desert, but to make the desert permanently sustainable. Along the canal, engineers installed automated sensors connected to central control systems. These devices monitor every aspect of the network: flow rate, temperature, pH, and mineral content. Artificial intelligence predicts consumption patterns, detects leaks, and automatically adjusts gates and valves to maintain balance. It is a living, self-regulated infrastructure, a water system that thinks for itself. The results are visible everywhere. Cities such as Beersheba, once a dusty outpost, have become vibrant urban centers with parks, fountains, and gardens. Industries in the region, from food production to technology, depend on the constant water supply flowing from the desert canals. Solar power plants spread across the horizon, providing clean energy for the desalination facilities. What began as a survival project evolved into an environmental model, in which water and energy work together to sustain life in one of the harshest climates on Earth. This transformation also changed the way the world views Israel. Countries from Africa to the Middle East, from India to California, began studying this model. Delegations arrived to understand how a nation with so few natural water resources achieved complete water independence. Many adopted Israeli methods: desalination plants, drip irrigation, and wastewater recycling, proving that the principles developed in the Negev can help confront global water crises. Behind every success story, however, there is sacrifice. The Desert Water Project took more than 15 years to complete and involved thousands of workers, scientists, and engineers who spent months living under brutal desert conditions. Many faced heat stroke, sandstorms, and long periods away from their families. But the vision that kept them going was clear. One day, their work would make the desert bloom, and that perseverance paid off. The project's completion represented not only a technological milestone, but a symbolic victory. When the first potable water reached remote desert villages, children ran to fill their bottles. Schools organized ceremonies to honor the workers who made it possible. For the first time, people could grow their own food, drink safe water, and plan a future not dictated by drought. The symbolism of this achievement is profound. In the heart of the Middle East, a region often marked by conflict and division, Israel's canals and desalination systems became symbols of cooperation and hope. Water, once a source of tension, came to represent the possibility of unity. Israeli engineers now share their expertise with neighboring countries such as Jordan and Egypt through joint water management initiatives. The Negev, once a dead zone, has been transformed into a bridge that connects beyond borders. From an environmental standpoint, the impact has also been remarkable. The reintroduction of water brought back wildlife species long believed to be lost. Birds returned to migrate along new green corridors, and oases formed around reservoirs and irrigation ponds. The desert ecosystem, though artificial in origin, now sustains biodiversity on a scale not seen for generations. Still, the story is not without challenges. Maintaining such a vast network in the middle of the desert requires constant vigilance. Sandstorms can damage infrastructure, and the long-term environmental balance must be carefully managed to avoid excessive energy use or impacts on natural aquifers. Even so, Israeli engineers continue to adapt, integrating renewable energy sources and developing ever more efficient membranes and pumps for desalination. Each advancement makes the system more sustainable and less dependent on fossil fuels. As the decades pass, the Negev Desert has become more than a region. It has turned into a living laboratory of the future. Scientists study its transformation to understand how to achieve climate resilience in other arid regions around the world. The lessons learned there now influence policies in North Africa, the Arabian Peninsula, and even California, where drought threatens millions of people. For those who live in the Negev today, the canals are more than infrastructure. They are lifelines, reminders of how human determination can shape even the most hostile environments in favor of life. Walking alongside these canals, one can see farmers tending greenhouses full of tomatoes and peppers, children riding bicycles along waterside roads, and solar panels gleaming under the sun, all powered by the same sea that once seemed unreachable. The transformation of the Negev also redefined Israel's national identity. Once defined by scarcity and struggle, the nation came to see itself as a pioneer of sustainability. Its universities and research centers attract scientists from around the world to study water technologies, renewable energy, and agriculture in arid regions. The Negev, once an obstacle, became a classroom for the future of humanity. Following the entire journey of this project from beginning to end, there is something almost poetic about it. The sea, once too salty to drink, now sustains millions of people. The desert, once silent and lifeless, pulses with activity and growth. Future generations will look back on the early 21st century as the moment when Israel dared to rewrite its own geography. The story ends with a simple yet powerful truth. Israel did not conquer the desert by dominating nature, but by understanding it. Every canal, every plant, and every drop of water reflects a partnership between human intelligence and natural laws. The lesson offered to the world is timeless. Scarcity can be transformed into abundance through vision, discipline, and courage. By turning salt water into life, Israel proved that technology and confidence in human capability can overcome even the most impossible challenges. The canals of the Negev are not just rivers of water, they are rivers of hope, flowing through a land that once knew only thirst. And as long as they continue to flow, they will remain a reminder that with determination and imagination, even deserts can bloom.